Okay, today we're doing rational and irrational numbers. If you are in one of my classes, then I recommend you write this information at the top of page A, or you write it on your formula sheet that you have. So, here's what a rational number is. A rational number is a whole number that is positive or negative. 0 is a rational number. So, for example, a whole number that's positive or negative. Negative 25, that's a rational number. 32, okay, that's a rational number. Also, repeating decimals are rational. Let me give you an example. 1/3. If you do 1 divided by 3 in your calculator, it's 0.333, so forth and repeating. 2/3, that would be 0.66 and repeating. So 1/3 and 2/3 are a rational number. So all you have to do is put in your calculator to see, is it a repeating decimal? Terminating decimal. Terminating means it has an end. If you are terminated from your job just ended. So a terminating decimal, 3/4. If you do 3 divided by 4, that is 0.75. It has an end to it. It doesn't keep going on forever. Okay, 1/2. 1/2 is 0.5. It has an end to it. Okay, so rational numbers are whole numbers that are positive or negative, a repeating decimal, or a terminating decimal. All of these are rational numbers. An irrational number is exactly the opposite, a non-repeating decimal or a non-terminating decimal. In other words, a decimal that goes on forever and doesn't ever repeat itself. Pi is a irrational number. 3.14159 blah 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 blah. It goes on forever and it doesn't repeat itself. It is an irrational number. Square root of 2. If you put that in your calculator, I'm doing that right now, it is 1.4142 blah 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 blah, and it goes on forever. It goes on forever and it doesn't repeat itself. It is an irrational number. Alright, so let's look at some of these ones in your book. So you have these two categories written down either on your page in your workbook or on your formula sheet to look at to know the definitions. 30C number 2, negative 13. It's a whole number and it's positive or negative, so it is a rational number. That's rational. Square root of 19. If you don't know for sure, put it in your calculator, do square root of 19. That came out to some long, never-ending decimal. If it goes all the way to the end of your calculator screen, that means it keeps on going. Your calculator just can't show you the whole thing. 5, 8, 8, 9, and now when I say repeating, it has a pattern. Just because that repeats, there's no pattern to this. So it goes on forever. So that is irrational. 30C number 3, square root of 100. What is the square root of 100? 10. 10 is a whole number that's positive or negative, so that is a rational number. 30C number 4, 22 divided by 7. By the way, 22 over 7, that is the fractional value of pi. And that comes out to some 3.14 blah 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 blah. And so it keeps going on. A decimal that never ends and doesn't repeat itself is irrational. 30C number 5, 1.45. It's a decimal, but it doesn't keep going on forever. It has an end to it. So a decimal that does end, that terminates, is rational. Only never-ending decimals that don't repeat is irrational. An ending decimal is rational. 1/2. If you do that into your calculator and put it into a decimal, that is 0.5. It's a decimal that has an end. Decimals that have an end are rational. 30C number 9, 5 divided by 5. 5 divided by 5, 1. That's a whole number that's positive, so it is rational. 30C number 12, negative square root of 49. What is the square root of 49? Well, there's your negative in front. Square root of 49 is 7. That's a whole number that's positive or negative, so it is rational. Alright, so let's look at 30C number 18 and 19. They want you to graph this on a number line. They just want to make sure that you can graph. By the way, all the numbers that we are doing, rational and irrational numbers, are all real numbers. In Algebra 2, you get into imaginary numbers. So rational and irrational are all real numbers, and all real numbers can be graphed on a number line. So to graph negative 2.1, well, there's 0, there's negative 1, there's negative 2. We need to go negative 2 and a little bit more. So negative 2.1 would be somewhere like right in there. That would be negative 2.1. 30C number 19 wants you to graph square root of 20. I don't know where square root of 20 is on the graph, so I'm going to turn it into a decimal. So you need to do the square root of 20, which comes out to, I'm just rounding to 2 decimal places, 4.47, because it's an irrational number that keeps on going. So if I graphed it, I need to go positive 4, which is right here, and then almost halfway. That's close to 4.5, which is almost halfway. So somewhere right in there. Graphing is just an estimate. When it comes to decimals, I am just estimating where are those decimals in between there. Okay, now look at 30C number 14, true-false questions. Only rational numbers may be shown on a number line. That is false. We just graphed square root of 20, and that was irrational. You can graph all irrational and rational numbers on a number line because they are all real numbers. Real numbers can be graphed on a number line, which will answer this question, 30C16. Both rational and irrational numbers are real. Real means not imaginary. This is true. All rational and irrational numbers are real. In Algebra 2, you get into what's called imaginary numbers.